So let's talk about big data processing. This video will act as an introduction to big data, will form that necessary intuition, that necessary building blocks that would help you understand the entire big data ecosystem. So, big data processing is all about a set of tools that help you process data in a distributed fashion. The idea is because one machine is not capable of processing a huge amount of data, we do divide and conquer. This essentially is big data processing. One machine not able to do something, you distribute it, get it done in a by leveraging a lot of hardware, right? Okay, so companies use this to process massive amount of data and extract insights out of it, train models, ML, like machine learning models that you have, to move data across databases into sales system, into advertisement business, into whatnot, right? So all of this is done through big data tools. Big data processing is literally all about processing huge amount of data, not just to do sums and counts and mins and max, but also to copy paste data in other place, transform the data, enrich the data. We'll take examples of all of these to understand, right? Okay, the key thing over here is you are all doing it on a commodity hardware. What does commodity hardware mean? Commodity hardware means that these are not specialized hardwares. These are normal general purpose computation hardwares that you get on any cloud. They are not very specific because specialized hardwares are very costly. These are commodity hardware which you can find anywhere. So let's take an example to understand where big data fits in. Let's say I want to count word frequency. And let's say I have a 1 terabyte of textual data set. Right now, for each word, I want to find out in that 1 TB of text data set how many times the word occurred. We'll start with a very simple approach. The very simple approach is you have that entire 1 TB data set on a machine. You read it character by character. As soon as you encounter a space, you update your in-memory hash map or a hash table. You create that word and put it in the hash table, that word frequency of word plus plus. Right? This is what you are doing. This requires you to traverse that entire 1 TB of text file exactly once. Prepare this hash map, right? Now here, the thing is that this is a simple approach that is running in order and time. You would say, hey, but why do you want to make it faster? You are doing it in any way, the more really efficient way. But now think of it, that it can take, can you make it faster? Can you parallelize it? Because this is something that looks very parallelizable. That hey, instead of me reading from first byte to last byte, can I not just use threads? That hey, if I have, let's say, 10 threads, each thread reads 1/10 of the text and acts on it, it would be much faster, right? So obviously you are seeing order n, you would say what's better than order n? You have multiple cores on your machine, do those things in parallel. What's stopping you from doing those things in parallel? Literally nothing. So you can easily parallelize this code and create each thread to handle a chunk of data. Let's say you create 10 threads, each thread would handle 100 GB of data. Problem solved. You get a 10x speed benefit out of it, right? But now think of it. Instead of 1 TB, what if data is 10 TB? Something that cannot fit on one machine. Data is huge, processing is huge, computation is, something is wrong. Right? Something is huge that is beyond the capability of a particular machine. Now, or even if it is not, let's say the computation itself is slow and your computation can be parallelized. Should you not do it? Of course you should. Right? Here we just spin up 10 threads. What if I spin up 100 threads? But if you only have 2 CPU, then what will 100 threads do? Nothing. But if you have 10 machines, each machine you spin 2 threads, you'll do overall processing much faster. This is what you're trying to do. You're trying to distribute the computation across multiple machines and get the output sooner than ever. This is where you are leveraging the distributed computational capabilities. Now, imagine you do not have a big data processing tool. Let's understand what distributed computing would be. How would you do that? So, the idea is that you would want to leverage multiple computers, each computer has multiple CPUs, You are just leveraging, you are not just using one computer having 2 or 4 CPUs. You are having 10 or 20 such machines. So you have large number of CPUs to get those things done. So what you will do is you will split the file into partitions. Let's say 10 partitions, each of 100 GB. You distribute this partition across multiple servers. So let's say you have 10 servers, you create 10 partition, you give one partition to each server. Let each server compute the word frequency independently on that. Then it sends this word frequency to one machine which combines the results and sends back to you the result. This is exactly what distributed computing or big data processing is all about. So the flow would look something like this. Let's say you have 4 machines to do things, but out of those 4 machines, you make one machine the coordinator. You will not submit job to all of them. You will submit job to one of those machine. That machine would then split the file into partition, put it into each of the worker, ask it to process that chunk, compute the word frequency map, send it to the coordinator, and coordinator will tell the user ki job done. Right? So now this coordinator is the one that is coordinating the execution of the job across multiple machines, gathering the result and sending the result back to the user. Now think about it. What about failures? What if one machine while processing that 100 GB partition crashed? Who will take care of recovery? Who is ensuring the completion? Let's say a machine partially computed the result and sent it back. Who takes care of completion? What if this machine never did but it never sent the response? Who takes care of completion then? Right? So someone has to take that ownership, which is where this coordinator would do. But now think of it. Do we have to write this coordinator every time we want to do this? Can this not be taken care of once by a good open source tool? This is exactly what Big Data Tool does. That we just take care of writing the business logic, and the tool, whichever we are using, takes care of failures, recovery, scaling, completion, error reporting, logging, transformation, whatnot. This is the essence of big data processing. One node not able to do that, distributing it, but who takes care of distribution, who takes care of completion, who ensures everything? The tool ensures it. When I say the tool ensures it, one process in that tool ensures it, typically the coordinator process. Every tool has a different terminology, FYI. Right? The idea is, this is where your big data tool comes in. Big data tool makes your life so simple. Plus, when the job is complete, big data tool takes care of cleaning up things, cleaning up temporary files and whatnot, making it prepared for the next job that is coming to execute on that. You don't have to worry about it at all. This is where big data tools shine. They take care of all the heavy lifting, all the mundane things. The people have implemented it just once, open sourced it, everyone is just using it. Two very good examples of big data tools are Spark and Flink. There are a plethora out there, huge number of tools out there. Each one solves a specific niche. These two you should definitely know about, right? Okay. So what Spark does is Spark takes care of large scale data processing. Exactly what I just explained on commodity hardware. One of the Spark node is the master, everyone else is the worker. They do what you ask them to do. Spark will take care of distribution. Spark will take care of completion. Even if one of the node goes down, it would ensure that it is sending it to any other available node to get it answered. For example, in case of word frequency that we were computing, let's say this worker went down. Right? Now this coordinator will know that, hey, this worker was responsible for this chunk. I will take this chunk and give it to other worker which is available. So coordinator's job is to ensure the completion of it, to ensure the thorough completion of the job. Spark does that for you. You don't have to worry about it. That's what Spark does, right? That's the job of the big data processing tool. So for example, let's say you want to combine your users database, your orders database, your payments database, your logistic database, and put them into a data warehouse like Amazon Redshift. Who will do that? There is huge amount of data that you need to read and put it there. And maybe one database is MySQL, one is Postgres, one is MongoDB, one is something else. Spark has connectors for every one of them. You write it like some good open source folks have write it once. You just have to use it. You don't have to rebuild that entire stuff again. Spark will do it for you. Right? So in Spark, you just write a business logic. Read this, read this, read this. This is how you merge it. This is how you write it. So it has connectors to all possible databases and all possible warehouses and sinks and whatnot. right? Spark will do it for you. This is where your big data processing shines. Now imagine one machine reading data from all this database, merging it, transforming it, and putting it. Very slow. Doing it in a distributed way is so fast, which is where you leverage distributed computing through Spark. Spark has native integrations with or native connectors for almost all popular databases out there. Problem solved. You don't have to write it. You don't have to know the dialect of the database. You just use simple data frames to use that. And that's the beauty of existing big data tools. You don't have to worry about a lot of mundane things. It will take care of completion. It will ensure that no line or no row or no document is missed. That's what its role is. It would ensure completion no matter what. Right? Okay, another example. Let's say want to have, let's say I'm getting a lot of events being ingested into Kafka, some user facing events. Now what I want to do is I want to enrich those events. Let's say a blog is published. I want to enrich those events with, hey, who published the blog? Who did the user make the payment or not? Is this a paid user or not? And then I want to send those events to Elasticsearch so that my CEO can visualize it. Now Spark is the one that will take care of making this call, merging it, enriching it, and whatnot. You will write that logic. You will write that Spark business logic, but doing it in a distributed way, doing it quickly is what Spark will do, because this is high throughput thing. One machine will not be able to make 2 database calls, enrich the information, make a 3rd database call to update it. This needs to be done in a distributed way, which means multiple machines would be there who would be reading from the Kafka, making call to this database, enriching the information, putting it into Elasticsearch for visualization by your CEO. This is where big data computing comes in. Big data computing is not just about doing sums and averages and percentiles and whatnot. It's about computing. Anything that you would want to do in a distributed fashion can be taken care by a good distributed processing tool like Spark. Spark is the most famous one out there. So that's why I'm heavily using Spark. But the thing is that there are tons and tons of tools available out there. And each tool solves a very niche problem. Just check out DuckDB. Just check out Flink, Flume, NiFi, Pinot. There are huge number of Apache open source softwares. Apache has a plethora of big data processing tools. Highly recommend you to check them out. You may need to know few of them. Spark is definitely one of them. Everything else is optional, but Spark you should definitely know really well. But this remains the concept of big data processing no matter which tool you are using. The tool always takes care of distribution and basic problem solving for you, like handling mundane tasks, ensuring completion, ensuring failure, ensuring recovery, so that you focus only on the business logic. You don't have to reinvent the wheel again. This is exactly what any and every big data engineering tool or data engineering tool will do for you. What you need to know is how to use that tool. So Apache Airflow, Apache Airflow, Airbyte, Spark, Hadoop, HDFS for distributed storage, MapReduce, then Pinot, NiFi. I can name so many. Folks who work in the data engineering domain, they would easily be able to relate. But in case if you are not, do a Google search. Know at least one big data processing tool, and my personal recommendation is Apache Spark. So as part of this exercise, what I want you to do to understand Spark is set up Spark locally, number 1. Number 2 is take some sample data set. There are many data sets which are available, right? You take some sample data sets and write Spark jobs to process those data. It is better to take sales data set. Typically, you will find sales data set only, but I'm being explicit about it. Refer any YouTube channel. There is nothing specific. There is nothing like best resource. Right now, you are starting up. Pick anyone that you find is okay to understand. You start writing. Writing code is more important than finding the best resource out there. Right? Refer to any series on YouTube and just get started. To start code it out, right? Generate insights out of it. You'll understand how to work with Spark data frames. You'll understand what Spark actually does. What does it mean when I say it's doing distributed computation? Just do it on local machine. You don't need multiple machines even for that. Just do it on local machine to build an understanding. And then once you do this, once you get bit of grip on Spark, write a Spark job that reads from Apache Kafka. For each event, it goes to, so here I'm talking about enrichment. So let's say you are getting a blog publish event in Kafka. So here what I'm trying you all to do is I'm suggesting you all to connect Spark with Kafka. This is where your stream processing comes in. Spark has streaming. So Spark streaming is a streaming module in Spark that you should definitely know. So what it does is you would connect it with Kafka. It would process things in streams as and when they are happening, and you'd want to enrich it. For example, let's say you get blog published event in Apache Kafka with some payload as this is user ID, this is blog ID. Now what you should do in your Spark job is you talk to users database and take the user detailed information and put all this information on the disk. So you take this event, you take the user information from it, and you publish this data locally on the disk. That's it. For each event, you are just enriching and putting it on the. Ideally, you should put it in some database, but that's okay. We want to understand Spark streaming. We don't want to understand how to write to a database. That's a simple part, right? But for you to understand Spark streaming, this is a very good example to get started. So what you need to do, just to reiterate, assume that there are a bunch of events in Kafka around blog publish. You have to publish that event in Kafka, write a Spark job that consumes it. Once you consumed it, you enrich it by making call to users DB to get the data, put that final JSON with users detail in it. So this was your payload. The details that you put in, you flush it onto the disk into different JSON files. This is what I want you to do to build a detailed understanding of Apache Spark and Spark streaming. That would go a very long way. You would find it very amusing to learn and have a fun while implementing it. And yes, this is all what I wanted to cover about an intro to big data tools. There are tons of tools available out there. Pick few of them, but start with Spark, most essential of all. Start with Spark streaming. Everything else is optional. Once you start building an interest on this, you will have a time of your life using it in real systems out there. And yeah, this is all what I wanted to cover in this one. I hope you found it interesting. Hope you found it amusing. That's it for this one. I'll see you in the next one. Thanks a ton.